And now let us try another. It's not a numerical, it is a theoretical derivation. Projectile motion 12, lesson 12. The lesson 11 video was not properly uploaded. The video is not clear. I will upload it once more. Now, equation of trajectory of a projectile. Look, this is your ground, x-axis. Your y-axis is your vertical. Means like this. And the projectile is traveling like this, right? And now, from the point O, use the velocity of projection at O, making angle theta with the horizontal. So theta is the angle of projection. So from this point, if you drop a perpendicular, this much part, that is u cos theta, is your horizontal component, this much part. From here, if you drop a perpendicular, this much part is your vertical component, that is u sin theta. Now, as you know, this u cos theta remains constant all throughout, because there is no retardation to this side, no acceleration to this side. No retardation because there is no air resistance. So this remains u cos theta all throughout. Here it is u cos theta, here also u cos theta, here also u cos theta, here also u cos theta, and so on up to point C. But u sin theta gradually decreases because Earth is pulling it down. So this becomes gradually 0 here, then finally increases, and at C also it becomes u sin theta downward, right? So your u cos theta is your horizontal component of u sin theta the vertical component of this velocity u. Now consider a point on the path of the projectile, right? The path followed is this. D is a point. From here, if I drop a perpendicular, this distance from here to here I have represented as x, the distance traveled along x-axis. From here to here is the distance traveled along y-axis. So the coordinates are x and y. So the x distance from here to here, which is represented as x, is traveled due to u cos theta, and this y is traveled due to u sin theta. So let t, small t, is the time required to reach the point t, small t. So therefore this distance from O to this point on the ground, which is x, is traveled due to u cos theta at constant velocity. So this x will be equal to speed into time. So u cos theta come to this side. So your t becomes x over u cos theta. Fine. Now let us find out y. This y distance is traveled due to u sin theta, and Earth's acceleration is this way. This acceleration is opposite to this velocity. So your acceleration is negative of g. So use s is equal to ut plus half at square along y-axis. So for s I put y because that has this y. U is your u sin theta because that is the velocity that is carrying it upward. T is t. And a is minus g, so I put minus g half t square. Now substitute this value of t here and here. T x over u cos theta, t x over u cos theta, square of that. Now so here your u cancels, sin theta over cos theta is tan theta, so it becomes x tan theta minus half g x square over u square cos square theta, right? So let us simplify this. Very simple. So let us simplify this. Y x tan theta, g this x square is here, 1 over cos square theta is secant square theta, I have written here, so that will be in the numerator, 2u square. Now this is called, equation 1 is called the equation of the trajectory, because I have considered any random point D on the path, and for that point D on the path, this is a relation between the two coordinates x and y, therefore is called the equation. Means if you know this, you can construct a path. It's called the equation of the trajectory. Now this is of this form: y x A is your tan theta. A is not acceleration. A is a constant. Tan theta is a constant. How? The moment you are throwing with certain angle, theta is constant, so tan theta is constant. Means you cannot say that you are throwing the projectile at the same time at two different angles. Whenever you are throwing, there is a given angle, so theta is constant, so tan theta is also constant. This part is also a constant. Look, you are throwing with a given velocity u and theta is constant, so g constant, secant theta is constant, square of that is constant, u square constant, so this whole thing is a constant. I represent as p, so v is a constant. Now in mathematics, an equation of this form represents a parabola, so the nature of the trajectory is a parabola. Now let us modify this equation 1. This equation 1, y, x tan theta, I take common. X tan theta into 1 is x tan theta. X tan theta into this is also this. Because when you multiply this x tan theta with this, x tan theta cancels. So I am left with x square g secant square theta over 2u square. That is same thing as this. Now, then what happens? 1x cancels. So your y, x tan theta 1 minus, I have to rewrite this. Now secant square theta is 1 over cos square theta, 1 over cos square theta, g remains as g, 2u square. This tan theta is equal to sin theta over cos theta, which will write it here. Now x tan theta 1 minus g over 2u square cos square theta. Tan theta here is sin theta over cos theta. Cos theta comes to numerator, leaving behind sin theta in the denominator. Now 1 cos theta cancels, leaving behind 1 cos theta in the denominator. So x tan theta, this is 1 minus g into x, gx, u square to 2 sin theta cos theta. So this much part is nothing but your sin 2 theta. Same thing as this much part is your sin 2 theta. And I bring g from the numerator to the denominator. It was multiplied here, so when it comes to the denominator, it will be divided. By doing so, this becomes the range of the projectile, which I have represented as r. So your y becomes x tan theta into 1 minus x over r, where r is the range of the projectile. That is from here to here. It is represented as capital R.